All right, my friends, let's start by looking at the integral from 0 to 2 of 1 over x dx here. I personally think it's most empowering to visualize these graphically. So I'm just going to graph y equals 1 over x, or at least, actually, let me change this a little bit. Or at least the part of y equals 1 over x that kind of matters for this particular problem. So here is, a half of the graph of y equals 1 over x. And the region described by this integral, starting at 0 and stopping at 2, it's not fully enclosed. You can kind of see, even though you've got this, graph kind of getting infinitely close to being closed out, there will always be kind of like, in a way, like a little leak in the graph. So let's talk about how you would set this up. So you could see that if the integral goes from 0 to 2, hopefully it makes sense. The region that we would be essentially finding the area of is all of that region is to the right of that lower bound. And so to get this problem set up, you could take the limit as a approaches 0 from the right of the integral from a to 2 of 1 over x dx. There we go. Like so. Anyway, and then at that point, this problem gets pretty repetitive with what we've already done in this lesson. So I just wanted to mention, just kind of how to get this thing set up. So now let's look at the integral from 0 to 2 of 1 over x minus 1 dx. For this one, same thing. I think you're really going to be most empowered if you can think about these graphically. 1 over x minus 1 is just a 1 over x graph that got shifted to the right 1 unit. So it would look, I guess, something like this. So if you start kind of thinking graphically about what you're finding, from 0 to 2 here. What's so improper about this integral? It would be this vertical asymptote that you have. So basically the point of this example is to make you aware that it's not just horizontal asymptotes. It's not just if one of your bounds is infinity, but if you have like a vertical asymptote where your graph exhibits infinite behavior, like here at this vertical asymptote, then that would be another type of improper integral. So to fix this integral, there are a couple different ways, but to fix the integral from 0 to 2 of 1 over x minus 1 dx, or to get started on it, really what you would do is, in a way, break this up into two, take this very improper integral and swap it out for two improper integrals. So one would be from the integral from 0 to 1, but from coming at 1 from the left side. That would be defining this, little left side here of the region. And then you could add the integral from 1, but coming at it from the right side, all the way to 2. Like that. And then, and then at that point, you'd be defining this little piece over here. Hopefully that makes sense. Anyway, and then notation, if you're going to be, really careful about your notation, then on the first one, you could have the limit as b approaches 1 from the left of the integral from 0 to b of 1 over x minus 1 dx. And then on the second integral, you could have the limit as a approaches 1 from the right of the integral from a to 2 of 1 over x minus 1 dx, like that. So anyway, and then, you'd have more grunge work to do there, but hopefully the point is watch out for vertical asymptotes as you move forward. Hopefully that makes sense. That's what I have to say about that. All right, my friends, with that said, let's have you take a look at example 5, see if you can evaluate each integral. and do your best. Check in with me in the next video.